Good afternoon again. We are having a meteorology session now as per the timetable. If you remember last when we met for meteorology, we had started the discussion on ice. We saw some forms of ice, some names given to ice. We saw how iceberg formed, right? We started the discussion. So we continue with that. Next topic listed is international ice patrol. Inside the syllabus, international ice patrol. So this is coming actually from chapter 5 of SOLAS. The origin is chapter 5 SOLAS regulation 6 and this titled Ice Patrol Service. So we can have a look at that, and also some part we will devote also to navigation in the ice. Let us begin. So as we said, chapter 5 regulation 6 of SOLAS. This is talking about ice patrol or international ice patrol, IIP in short. It is supposed to contribute to safety of life at sea as per SOLAS, efficiency of navigation and protection of the marine environment in North Atlantic. Ships transiting this region of icebergs are guarded by ice patrol during the season and are required to make use of the services provided by ice patrol to maintain the sanctity of safety and efficiency of navigation. This is from the SOLAS chapter 5. We can have a look at straight from the SOLAS itself. SOLAS chapter 5. As you can see, shared screen is possible. Among many subjects included in chapter 5 SOLAS, one is what we are talking about today is the International Ice Patrol Service, this one. As we say, chapter 5 regulation 6 Ice Patrol Service. This contributes to safety of life at sea, the ice patrol service, and this is recommended to be used, actually mandatory to be used for any ship transiting the areas described under ice patrol. It says during the whole of the ice season. So what is the ice season as far as the chapter is concerned? Period from 15th February through 1st July of each year. That is the ice season as far as chapter 5 is concerned. This one. So contracting governments. Who will be the contracting governments? Who will be the contracting governments as far as this chapter is concerned? Or the line written here, the contracting governments undertake. Who will be the contracting governments? Well, you must remember this. Contracting governments, as far as this line is concerned, are the governments who have ratified SOLAS, simply who have ratified SOLAS. Of course, as we know, there will be hardly anybody who has not ratified. But by definition, contracting governments are those governments who have ratified SOLAS Convention. So it talks about the contracting governments to undertake ice patrol for the study and observation of ice conditions in North Atlantic during the whole of this ice season. This is where we had stopped. Ice season described as period from 15th February through 1st July of each year. Not only that, the southeastern, southern, and southwestern limits of region of icebergs in the vicinity of Grand Banks or Newfoundland shall be guarded. This is for the purpose of informing passing ships of the extent of dangerous ice. That's the idea for establishing the ice patrol to safeguard shipping. So the season is by description from the chapter starting from period from 15th February to 1st July. But it goes on to say during the rest of the season, rest of the year rather, the study and observation of ice condition shall be maintained as advisable by the government for, like USA has taken up overall arrangement management for the ice patrol, so they are the ones who will advise. The government of the United States of America has agreed to continue the overall management of the ice patrol service and the study and operational conditions. This one. Some ships and aircrafts could be assigned or could be nominated for ice patrol service and observation for conditions. Now, it is very clearly remarked here that these duties will be in addition to their normal duties. Primary purpose is not going to be impaired at the cost of this service, which they are providing as an additional help. So this is straight from SOLAS chapter 5, regulation 6, this one. Okay, we'll come back to it. This is where we had started. This is also talking about the same thing, period from 15th February through 1st July each year. And then it goes on to say ships and aircraft used for this ice service, patrol, etc. will continue to do their assigned duties apart from this uh, voluntary service like for ice patrol. Government of USA is the one who will manage the overall services. If United States and or Canadian governments so desire to discontinue providing such services, then they can do so, but then they have to inform the contracting governments of discontinuation. They cannot just abruptly stop. Not only that, these governments of US and Canadian governments, which are, have voluntarily taken up the management of services, will give 18 months written notice to all contracting governments. So the services cannot be abruptly stopped. But yes, the chapter does permit the US or the Canadian governments to stop the services if they want by giving 18 months written notice. Have a look at this. This is something importance, objective of International Ice Patrol Service. Objective. You will need to just comment this to memory. Contribute safety of life at sea, which is actually solar system. Protection of marine environment is a byproduct. When you are contributing to safety of life at sea, in retrospect or as a byproduct, you're also protecting the marine environment. If life is maintained safely, then of course marine environment will also be just by as a fallback will be protected also. Those are the two objectives just to start with. Contribution towards safety of life at sea and safety of navigation and protection of marine environment. Extent of iceberg danger is also monitored and reported near the Grand Banks of Newfoundland, the main area. Extent of iceberg danger is also reported. So, what is the necessity of having IIP, ice patrol? This is the part which is playing importance. You are aware there is a Labrador current flowing at the coast of Newfoundland, cold Labrador current. This carries some icebergs in the vicinity of Grand Banks. And this actually travels into the Great Circle routes of shipping between Europe and major ports of East Coast. This is creating a hindrance. Great Lakes, no, sorry, not Great Lakes, Grand Banks, and the Great Circle shipping routes. You follow GC route from either Europe to the major ports of East Coast of US, New Norfolk or maybe Philadelphia, and also vice versa from Newfoundland to Europe. That is a GC route, and this will carry or bring the ship in vicinity of icebergs, which is being carried across by cold Labrador current. So when they are going downwards, this cold Labrador current will meet what is the warm Gulf Stream. Temperature differences are something like 20 degrees. This, by meeting of the cold Labrador with the warm Gulf Stream, gives rise to fog, dense fog actually. So this creates a hazard. because combination of iceberg, fog, severe storms is making shipping lanes dangerous. That is why IIP International Ice Patrol was developed so that shipping in the vicinity can be warned of sighted icebergs. I mean, we are looking at the objective why iceberg International Ice Patrol was established. So, what is the area of coverage of this patrol? North of 48 north in the North Atlantic Ocean. It does not extend beyond this. Total area of coverage on record is 500,000 square nautical miles. During the ice season, which has been described as 15 Feb to 1st July each year, ice survey detachment is deployed. Now, this particular service, it is called Reconnaissance RECDET, is deployed, which is consisting of Air 11 crew and 4 ice observers. This is deployed at St. John's to be closer to the ice area. Coast Guard operates a wing aircraft which conducts this survey. About 7 hours of flight covering an area of 30,000 square nautical miles. They are placed, these flights are placed at a track spacing 30 nautical miles to cover everything. They use some forward-looking airborne radars, side-looking airborne radars. They have this facility, they are equipped with these radars, they use this to uh, detect icebergs. Because you see, icebergs are to be reported by a ship if they sight one. If they sight unreported iceberg, you are aware they are supposed to report it. But this is making it more objective because this is a dedicated service. Although sighted icebergs are to be reported by ships who sight them, prefixed by the message TTT. Prefixed by message TTT. Iceberg sighted in so and so position. Unreported iceberg. So this is required by the ship, any ship, to report the position and time of all ice sighted, along with the sea surface temperature and weather reports to this patrol center every 6 hours when in the vicinity of Grand Banks. This data is then fed into the computers at the IIP Operation Center along with the ocean current and wind data. Using this information, the model will then computerize printout for drift of iceberg, means probable drift of the icebergs. Consequently, you also have what is called ice bulletin from radio stations around US, Canada, and Europe. Ice stations or ice bulletin from ice stations. Radio stations broadcast what is called ice bulletin. They recognize the seriousness of the problem. This is broadcast twice daily. So what is success rate? Good one, because except for the World War years, IIP has operated every ice season since 1913. Why is this year important? 1913. Does it strike a chord to you? 1913, 1913. What chord does it strike to you? Okay, I rephrase. Can you recall the accident of Titanic? Which year? You remember Titanic meeting with an iceberg, colliding with iceberg? Which year was that? 1912, 1912. Therefore, it was recognized that a service like this is important. So, consequently, this was developed. So, how do they do it? Actually, they do it by marking them. See, icebergs will all look the same, except for their appearance. They will all look the same. Therefore, to track them, they put marks, electronic position beacons on them. They are called the electronic position beacons. They are placed on the iceberg and then they are tracked. But there was a problem regarding these markers getting washed away or dislodged from the iceberg. And also there was problem placing these marks because of the shape and orientation changing of the iceberg or iceberg breaking itself. Therefore, this aerial reconnaissance as the primary method was selected for monitoring icebergs. Apart from IIP, International Ice Patrol, you have some more services like Canadian Ice Service, Danish Meteorological Institute Service. You have these also. But mostly, more importantly, it is always IIP, International Ice Patrol. Okay, now there is another mention as to this is okay. SOLAS Chapter 5, Regulation 6. This talks about ice patrol, etc. 1 minute. Just give me a minute. Inside the chapter 5, safety of navigation, included is this information also. Chapter 5, safety of navigation, talks about information required in danger messages. So, if we are talking of ice, which is our subject today, then information required in danger messages to be sent is ice, the kind of ice, derelict or danger chhod do. We are dealing only with ice so far, but actually it talks about ice, derelicts and other dangers, direct dangers to navigation. Information required in a danger message regarding ice. The kind of ice, the position of ice, when was it observed, date and time in UTC. This one. The following information is required. Please remember, it is part of the syllabus, so just make a note. Information in radio messages reporting dangerous eyes. Can you see it? Information in radio messages reporting dangerous eyes. This is part of the syllabus. Get the point? Please note it down. Of course, this is already we have covered different types of ice, icebergs, etc. And we are going into accumulation of ice, etc. But information required is also something to be carefully understood. Information required. So we are looking at it. If you want to note down, it's up to you. Information required in danger messages pertaining to ice. Actually, it is not talking only of ice. The Solar Chapter 5 is talking of ice, derelict, and other direct danger. But ice is included. So this information is required by Solar Chapter 5. In short, the kind of ice observed, position of ice, when observed, and date and time in UTC. To continue, not only ice actually, sub-freezing air temperature accompanied by a gale force wind causing severe ice accretion on superstructure is also to be reported. Sub-freezing air temperatures associated with gale force winds, which may cause ice accretion on superstructure, is also to be reported. This is also a danger which is to be reported. Right? An example of the message is like this. All these messages will start with TTT, Tango, Tango, Tango. Then prefix is the TTT, ice, and then the message. Large iceberg sighted, 4506 north, 4410 west, at 0800 UTC, May 15. This is how the message will begin. Will be coined or framed. And then, of course, there are other dangers, but right now our topic is ice. But you could have a reporting of derelict, danger to navigation, tropical cyclone, etc. Not reported ones. You see, danger to navigation, interesting one. Alpha light ship, not in station, means could not sight it. It is not there. The light ship reported missing. This is also going to go as a TTT message. Anyway, that will take it too far. But what we are interested right now is the issue about ice reporting. This one. Okay, got the gist. What is to be reported, how it is to be reported, right? Suppose this will continue, solar chapter 5. No, we'll leave it because we were only considering ice thing. Then we can leave it. Now, another thing is warnings of ice in vicinity, and along with it we also have what is called ice accretion. So let's go one by one. Let's first start with what is called warnings of ice in vicinity. Sea ice warning, warning signs. Whitish or yellowish haze during clear daylight. Whitish clear, indication of sea ice. Whitish clear because this is being reflected from the iceberg. So it will have a whitish glare. You can see a glare in the vicinity. It is a clear indication that of course, one thing is certain, you must be in the ice zone, in the ice prone area, obviously. That is and if you see a white glare or an orange glare, yellowish glare, then you are aware there is an indication of sea ice. Just in case the swell starts to lessen because it has been blocked by the iceberg, or if there is a distinct and quick smoothing of the sea. This indicates ice because this has been blocked by the presence of the iceberg. The swell broken by the iceberg. So you have a swell and suddenly it starts to lessen. Again, I will repeat, you must be in the ice area, ice limits. Then of course this is going to indicate there is presence of iceberg. Iceberg warning signs. See, the vessel is far away from land in the mid ocean, but there appears to be no effect on the sea state by the wind. Wind is blowing, but the swell is not picking up, or the fetch of the sea is not picking up. It means it is an indication there is iceberg to the windward. That is why it is getting blocked. If you see smaller pieces of ice, of course, then it is indicating iceberg is close by and it is breaking up. That is why you are seeing smaller pieces of ice like growler or buggy bits. You can also have a sound of sea breaking as if it is from sea breaking against a beach or a land. Then, of course, since you're far away from land itself, it means there is some thunderous noise seen, heard, which indicates icebergs are present. That is why you're hearing these sounds. Please note, these sounds are produced as the icebergs are carved. Do you remember what is carved? What is the meaning of carved? This one. It means the iceberg is breaking up and it is taking a different shape. That is called carving. If you are having fog, the iceberg in a distance can be observed or may appear as a luminous white mass. Then, of course, you can suspect iceberg. It is also possible on clear nights With no moon, icebergs visible at a distance of around 1 to 2 miles as white or black objects, depending on what light reflection they are throwing back. You can have a misunderstanding also with cumulus and cumulonimbus clouds in distance that can cause the impression of icebergs at night, but they are not icebergs. It may be cumulonimbus dark cloud. Of course, these methods are not accurate, but they do indicate something and make you more more careful. Of course, navigation in ice is a completely different subject. We can have a look at it also, but it is entirely different. Navigation in ice is a whole time subject. ठीक है थोड़ा सा देख लेंगे. We will have a concise look at it. Not part of our syllabus in meteorology. You should not enter ice area, of course. If you want to have a go at the ice area, then you must be accompanied by icebreaker, or you should be ice class ship. You should be classed to navigate in ice. Ice classification should be done. 100A1, something like that. If you have to enter, preferably it should be in daylight hours. Entry actually should be made at right angles to the edge and slow speed. Speed is very, very imperative. Slow speed is very, very imperative. Most important. Speed should not be exceeded. Speed should be under control one and should be slow. And of course, some common things which will be taken care of. Good working condition, the vessel, hull, machinery, steering gear, all good working and safe operation. Bunker store actually adequately stocked for the voyage, which is now going to be elongated because we're going to go at slow speed. Maybe the voyage will be elongated, so ship's bunker and stores must be adequately stocked. The passage plan will have to be completely reviewed again. If you are entering ice, you have to review the passage plan. It will take a different turn altogether. Anyway, let us have a look at ice accretion. This one. You heard of this term, ice accretion? What is it actually by definition? Ice accumulation. We have to look at factors which cause this and then how to reduce this effect. Ice accumulation on board ships. It has a threat. Yes, of course, it has one. And this threat will be be heightened by stability, icing, and damage to radio and navigation equipment. The ice accretion could be simply caused by precipitation, freshwater icing. Could be simply caused by precipitation, fog, and water vapor melting. Cause of seawater rising will be ocean spray, of course. Accumulation of ice will depend on meteorological conditions and vessel design. And of course, conditions which promote icing will be like this. Seawater, cold seawater temperatures, 7 degrees Celsius or lesser, below freezing air temperature, which is minus 1.7 degrees Celsius and lesser, strong winds greater or equal to 18 knots. This will promote ice accretion. Factors which will promote ice accretion: cold sea temperature, below freezing air temperature, and strong winds. Vessel design, of course, is going to play a part. The more exposed the vessel is to sea spray, the greater chance of ice accretion. Does it have an effect on stability, vessel stability, ice accretion? Or will it have an effect? What do you say? On the stability of the vessel? Are you there? Or you guys don't seem to be interested for some reason. I don't know. I'm not doing anything about away from the syllabus. It is part of the syllabus. But you're not responding. So gives me a doubt whether you're actually there or not. Are you with me, gentlemen? Are you listening, candidates? Since you're not responding, it becomes a doubtful case.
Yes, sir. Yes, sir.
Yes,
Listen.
sir.
Okay, okay,
Yes, sir.
Ghanshyam. Okay. So I had a small query I wanted to interact with. Does ice accretion has an impact on your stability of the vessel? Ice accretion.
Yes,
Will
sir.
it have?
It does.
Okay, it has. So a small interaction, how will it have an impact on the stability of the vessel?
Sir, it will increase the displacement of the vessel.
Okay. But you will agree this will take long time. Displacement कितना बढ़ जाएगा? How much? Right? But more importantly, it is going to add weight on top. If there is going to be any change in displacement, as you say, how will it take place? It will be adding weight on top, which means, kg of the vessel will kg of the vessel because you're adding weight on top. Superstructure, deck, cargo hold, hatch top, maybe containers. Then you're adding weight on top, and then the kg will move. Right? Kg will move due
Yes,
to
sir. It
added
will
weight.
move up.
Up, right, up, which means it is going to move closer to km. So consequently, you will have a reduction in GM. When you have reduction in GM, stability is affected. That is why ice accretion on superstructure or on top can have effect. Actually, if I can use the word, negative effect on the stability. After all, stability is a measure of the ability of a vessel to come upright when heeled by external forces. That is my definition of stability. If I am asked to describe stability, I would say the ability of a vessel to return upright if heeled by external forces is the measure of stability. So if you're going to compromise on GM, you're going to compromise on this healing. After all, it all boils down to writing moment Rm equal to W displacement into Gm sine theta for small angular field. So if this is going to be compromised, then Rm is going to get varied because Gm is going to vary. So anyway, not a part of discussion, but just as we came along, stability is going to be adversely affected if there is ice accretion on top. So ice accumulates on vessel, it raises center of gravity, lowers the freeboard, also negatively affects the stability. And of course, smaller vessels will be impacted more, including so much so that they can suddenly capsize. There have been cases of fishing trawlers who have been unfortunately capsized because of this ice accretion. They are fishing in very higher latitudes like Baltic Sea or maybe even north of Aleutian Islands, and then they have capsized due to ice accretion. And then if this ice accretion is settling on radio antennas, it is going to make communication difficult. Apart from this, we all agree accumulation of ice will result in hazardous working conditions on deck, all sizes of vessels. You may have ice accretion on top of containers loaded on deck. Now, when you reach a discharge port, you are having difficulty in discharging them, causing costly delays. These are the sources of ice accretion. Sources, all of them. Common ones, sources of ice accretion on ships. Freezing precipitation is going to lead to ice accretion. Rain or drizzle in sub-zero temperatures, this can also lead to ice accretion. So, ice accretion is an issue, and we have seen how this can cause adverse effects. But you must mention these effects clearly because this is what it says. I mean, this is what the real thing is, including measure of stability affected. Freezing spray, sub-zero temperatures, the sea is rough, and the spray is being formed at the sea, but the spray is freezing with the action of wind and waves against the ship, and the spray which is falling on the vessel is freezing. Freezing means this is going to contribute towards ice accretion. How do you control this? I mean, really you can't, but how can you try to control? Keep away from sea areas with critical air temperature and wind speed. That is one way. Seek shelter in the lee of the land until the conditions become more favorable. That is one another way. Reduce speed. Choose a course to run with the waves in order to limit the amount of icing, or head towards more favorable area where weather is better or temperatures are higher. Anti-icing deck mats could be used. Rubber coated canvas just for precaution. Electrical heating of certain parts of the ship like radar and antenna areas, radio antenna areas. This could be also done. Electrical heating, but very categorically stated, it is a no catch 22 situation because really you can't fight it out. What you can do, the best method I feel, is to keep away from these areas and also to alter course, to run with the waves so that you have minimum amount of icing or head towards more favorable area. Anti-icing mats is only for preventing accident. This will not reduce accretion. Use rubber coated canvas also for prevention of accidents. right? That is eye secretion, sources, and avoiding eye secretion. So navigation, ice navigation is something very complicated in one way that it is specialized. It is also termed as polar navigation in polar regions. Complicated, but of course it is being done. And obviously, if you do end up there, then this is how you will go about it. Right. You can end up uh, just by a few photographs of eye secretion. One is this one. We're looking at crew removing ice from bulwarks. These are the bulwarks. So much is the ice secretion that crew is deployed to remove it from bulwarks. Right? Or you could have something like this. Ice build up on forecastle. Then this is something slightly different. We'll come back to it. So what I suggest, gentlemen, is that We take a small Kit Kat coffee break. We come back and meet at 15:45 to continue. Okay. So these are the causes also from the Mariner's Handbook. Formation of ice from freshwater or seawater, and then accumulation on hull and superstructure, which can be called accretion. Freezing rain, freezing drizzle, all these will contribute to ice accretion. Spray or seawater breaking on the ship when air temperature is below the freezing point, about -2 degrees Celsius. Then you can have ice accretion. From fresh water, it will be fog, drizzle, rain, or snow. And the weight of ice which can accumulate may increase to such an extent that it is liable to fall and endanger those who are working on deck. Apart from the fact of causing concern regarding stability, etc., it is also a danger to people working on deck. Aerials, insulators can all be affected. Freshwater ice is in small comparison when compared with the amount which can accumulate in rough weather and low temperatures due to heavy seas, which is from seawater. This will happen when air temperature is below the freezing point of the seawater. Ship is moving in heavy seas, considerable amount of water will freeze onto the superstructure and those part of the hulls which are above the waterline. This amount of freezing onto the surfaces will increase with falling air and sea temperatures, and in extreme cases can lead to capsizing of vessels. But having said that, this is more pronounced in smaller vessels, including trawlers and fishing vessels operating, let us say, in higher latitudes like north of Aleutian Islands. Strong winds in combination with air temperature of -2 degrees Celsius something or maybe below can lead to this. There is of course diagrams also which indicate the rapidity with which ice accumulates. This will increase when the wind force increases above 4/6 and air temperature falls below -2. Ship speed and course relative to the wind and waves is also a factor which will influence the rapidity with which ice accretion can take place. Operating in ice is an entirely different thing. It is something to do with polar navigation. But avoiding is possible, avoiding ice accumulation. Although it is difficult to forecast accurately, but there are methods by which you can try and avoid ice accumulation. So one method is to steer or seek shelter as soon as possible, steer towards warmer conditions. You cannot stop ice, of course. You cannot stop the environmental impact, but what you can do is move away from it. Or head into a course which will cause lesser accumulation of ice, alter course. 1 minute, we come back to this. We have seen this. Just for a small recap, this is where you're supposed to make reports as per SOLAS chapter 5 also. For meeting dangerous ice, you are supposed to make these reports: type of ice, position of the ice, and UTC. Please remember, this is also part of the questions. When is the ice report required to be made? Not only when the ice is met, but also when you encounter air temperature below freezing associated with gale force winds, which causes severe icing. Then also you are supposed to make a report regarding like this: air and sea temperature, force and direction of wind, position of the ship, UTC, prefixed by TTT. International Ice Patrol, we have had a look, so we'll just skip that. One good method of operating in ice is to be under icebreaker or assist by icebreaker. There are of course methods to do it. It has to be employed. There are ways to do it. But icebreaker is one way where you can be assisted in case you are stuck with an ice navigation. Three rules do apply. Keep moving even if very slowly. In fact, you should move slowly, but keep moving. Try to move with the ice movement, not against it. Excessive speed can lead to ice damage. Do not underestimate the hardness of ice. Such is the extent of damage possible, which is bulwark bow of a cargo vessel, class 100A1, ice class, damage en route. The extent of damage could be something like this, so much so. Excessive speed is the major cause of damage to ships by ice. Excessive speed. So speed control is absolutely essential. These are the factors which affect in high latitudes: low surface temperatures, high winds, low seawater injection temperature means seawater temperatures are low, low humidity, ice conditions from slush ice to solid pack ice, slow, sleet, snow, sleet, freezing wind, fog and overcast, especially ice water interface. Of course, superstructure icing is very dangerous phenomena because it can lead to loss of stability, which we have discussed. Superstructure icing. This is severe icing conditions caused by sea waves against the forecastle deck and freezing as soon as they come on deck. This please something. No, just background noise. Ice formation can also be aggravated if shipped water is retained on board, on deck, for which purpose your scuppers must be free. Definitely, the ship's course relative to the wind and sea is a phenomena which will influence ice accretion. It is a function of ship's course relative to the wind and sea. So one way to break it is by altering course. These are the areas susceptible: the stem area, bulwark rails, windward side of the superstructure, deck houses, hose pipes, deck gear, forecastle deck, upper deck, etc. These are the susceptible areas. And maybe containers on deck, hatches, hatch tops, aerials, stays, shrouds. It is important to keep the anchor windlass free of ice so that the anchor can be used in emergency. Whenever the air temperature reaching minus 2.2 degrees Celsius or lesser, wind speeds are 17 knots or more, then severe icing is possible. If you have a combination of air temperatures less than minus 2.2 and winds more than 17 knots, then most likely icing is going to take place. Severe icing is going to take place. In freshwater lakes like Great Lakes, St. Lawrence River, etc., superstructure icing can begin at 0 degrees because they are freshwater, and this will accumulate faster than salt water. Just as generally speaking, wind force before 5 can produce light icing, force 7 moderate, and force 8 and above severe icing. Most intensive ice formation will take place when wind and sea come from ahead. In beam and quartering seas, ice accumulates faster, but on the windward side. Now, when it is accumulating only on the windward side, it can lead to a constant list, which is even more dangerous, especially if the vessel is a loaded vessel. This is one way to approach an ice field: reduce speed and perpendicular to the edge. This is one way prescribed to approach the ice field. Perpendicular to the edge. Of course, you approach it with lower ice concentration, perpendicular. Can you use the radar for ice detection? Radar targets, really can't distinguish between ship and iceberg. They cannot. They only show it as a blip. But from ice, there is another problem that the target is reflected poorly because of the ice low reflectivity of radar energy. So really speaking, radar cannot be absolutely relied upon because over reliance can lead to accident. The smooth edges of the flow, maybe poor reflectors, calm sea can give an appearance of ice flows, but these can be poor reflectors of the radar energy. Poor reflectivity and smooth surface. So the display cannot be absolutely relied upon, but of course it can be an aid to navigation. You cannot rely solely on radar for detection of icebergs. You see, if suddenly you have an absence of sea clutter, this can also indicate ice is present because the iceberg is preventing accumulation of sea clutter. So you had sea clutter and suddenly it dies down without any rhyme or reason. It means that ice is present because the sea clutter cannot suddenly die down. By observation, high power radars with 50 kilowatt output provide much better ice detection than 25 kilowatt radars. Similarly, 3 centimeter radars X-band are better ice detectors than 10 centimeter S-band because they show ice and ridging at a greater distance. But it is recommended that both wavelengths are periodically used to make sure that you are not missing out on it. It is only a tool, of course, you fully realize this for detection. You cannot rely solely on it. In fact, observations from ships, prediction centers like Environment Canada, storm prediction centers, they are better. They are the most reliable ones. Source of information. The best source of information is a ship who has reported ice. Direct observations from vessels are hence incorporated into weather maps. This is very, very important because this is 100% correct because the observation has been taken from the vessel itself. This can be relied upon. In fact, voluntary observatory fleet VOF in these regions like Hudson Strait, Grand Banks, etc., they are encouraged to make reports. As it is by SOLA Chapter 5, you are supposed to make a report. Information is then stored in the Canadian Climatic Center because those are the areas where ice is a concern, and then this data is used to evaluate and predict. Reports are also made mandatory like this. It is a must for all vessels operating in Arctic waters to provide a once daily position report so that charts and forecasts can be updated and transmission of updated charts can take place. These are free of cost, so no cost is involved. We come to a more important point which you can just pay attention to, which is prediction, icing conditions. Have a look at these diagrams. For records, they are called isonomograms. Have a look at this. These one, icing nomograms. Please note, they are called icing nomograms. Icing nomograms. This is the name given to these diagrams, icing nomograms. Don't be surprised if you are asked later something like this. What do you understand by icing nomograms? Then these are diagrams which are showing condition of icing, or this is showing you how icing can take place. And it is drawn icing conditions. This is drawn on icing nomograms and this is depicted like this. For seawater temperature, let us say plus 1 degree Celsius. We say the seawater temperature is plus 1 degree Celsius. Wind speed is depicted here on the x-axis, wind speed 0 knots, 20 knots, 40 knots, 60 knots, 80 knots. This is for seawater temperature assumed to be at plus 1 degrees Celsius. And then air temperature is predicted or marked on the y-axis in degrees Fahrenheit or degrees Celsius, like this. Minus 20, 16, 12, 8, 4, 0. Now we have got curves which show you how heavy icing can take place, moderate icing and light conditions. This part shaded blue is telling you an area of heavy icing. Then in between moderate and lastly light. This is called icing nomograms. Please note the word icing nomograms. This way. It is also described what is it. Like light icing means less than 0.7 centimeters per hour. When we say light icing condition, like here, this area, it is showing you light icing means less than 0.7 centimeter per hour. Moderate icing is 0.7 to 2 centimeter per hour. And heavy icing is greater than 2 centimeter per hour. I'll tell you why this is important. I will tell you why this is important. Apart from the fact that you're predicting icing, why this is important is this way. Use of Mariner's Handbook to estimate rate of ice accretion. Get this point? Use of Mariner's Handbook to estimate rate of ice accretion is from the syllabus. And this is what it looks like. Ice demogram. This is straight from the Mariner's Handbook. So diagrams are such that firstly, this one is showing you when the seawater temperature is plus 1 degree Celsius, then this is a condition. Or you can go further, when the seawater temperature is plus 3, then this is a condition. Again, on the x-axis you have the wind speed in knots, y-axis you have temperature of air in degrees Celsius and degrees Fahrenheit. And to go further, when you say the seawater temperature, let us say, is rising plus 5, plus 7, etc., then this is a condition. As you can see, the area outlined under the curve is getting bigger for heavy icing. If this is a condition, wind speed, but also to be noted that as wind speed is rising, the area is increasing. So these are icing nomograms. They are called that way. That is a name given to them. This is for wind speed in knots here and seawater temperature plus 7 degrees Celsius. Obviously, the diagram has a relation with both the seawater temperature and the air temperature. You see, if the wind speed is about 10 knots, somewhere here, 10 knots, and the air temperature is something like 0 degrees Celsius, then you are still in the light condition. Light icing will take place. On the other hand, if the wind speed is about 20 knots and air temperature is about minus 16 degrees Celsius, then you are in the moderate condition. Or maybe you can fall in the heavy condition with 40 knots wind speed. But more importantly to remember is one thing, that this is called icing nomogram, and secondly, this is how it is described: light icing, moderate icing, and heavy icing. I don't know if you would like to draw one for sample, or maybe you have the book, it's okay. Because what I have, I can share with you is only a screenshot. Let me see. I think I have a screenshot. So what I can do is I put it on your chat box, an example of icing nomogram, just as an example in your chat box. Can you open it, access it? Or otherwise, as you are aware, you can go back to this book itself and take a lead from there. This one. This is from Mariner's Handbook. The page number is here. Or on the chat box, you can find only one screenshot. Right? But do remember this name, because I will not be surprised if somebody puts up a question, what is the icing nomogram? And then he asks you to describe what is light icing, moderate icing, and heavy icing. If you're asked to draw a sketch, then one example is here in your chat box. Just as example, you can use this one. So what I'll do is I will use the link to put something over there regarding icing, etc. the meteorology on the link, which you can use to see, and you can confirm that you can see it. Just give me a minute. I will put it on the link, Google link. Okay, you have topics, 5 topics actually for the ice one. Navigation in ice covered waters, warnings of ice, icing nomogram, international ice patrol, ice accretion. All put on the link. Can you confirm you can see it and download it? It's on there on the link for your use. देख सकते हैं आप on the link that is. Nobody is confirming. Confirm you can see those 5 files on the link.
Yes, sir, can say.
Okay, thank you. That is for your use. So maybe you can go through them and also see what has been asked in past question papers. If there is any concern, you let me know. We can address it. So actually, this is it for the ice one. The covered topic is covered. Do you have anything to raise? As far as the topic is concerned, we are done with it. And what we'll do in the morning, cargo work fumigation. Yeah. Give me a minute. I will pass fumigation also on the link. Just a minute. Somebody wanted a note on Lodicator. Was that Lodicator? Let me put that also. Lodicator somebody wanted. And we are looking at fumigation. Yeah, that one is also on. So we are done. Okay. Since you're quiet, it means you have no question to be asked, query. So end the session. Before that, you need to respond to this.